Okay, the recording has started. So let me begin with today's session. So we have been going through OCaml values and functions. So let's continue going through that. We need to resume from defining global functions. So we can define a global definition and bind a function as defined here. So we have f is assigned this anonymous function which takes an int and returns an int, right? So this expression happens to be a function and it is bound to a name f. We can also have, say, g x is x into x. If I clear this and run it again, I get the same thing. The letter is compact syntax. It avoids the fun keyword and the arrow symbol. But the first example f basically is a definition for the let construct with the use of the anonymous function. These are like global functions. Similarly, we can define functions that are local. So let's say we have let square of x is x into x in square 7 into square 7. So let me run this again. So it returns the computation. But then if I try to get the value of SQ here, it basically says unbound value SQ, right? So here this is locally defined. SQ x is of x into x is in this expression here, which is a local definition, right? So anything outside that is throws an error unbound value in the output. Let's continue and now look at closures. So we have the example here, j is 2 times 3, and let's define k x as x into j. Let's quickly run it and check that, right? So j is 6 and we have a definition for k. If I call k of 7, j is 6, I'm passing 7 into 6, so it should basically return 42, which is as expected here, right? And then let's define j again to be 7, okay, instead of 6. And now if I ask for k of 7, what should be the value, right? Will it take the new value of j, or it's already this computation? So already is this computed value here, and that's what it returns as 42. Okay. So this is the an example of a closure inside the definition. We can also use the syntax here where we define m as j into 3, for example. Right, let's run this, and of course we get 21, which takes the new value of j, which is 7, right? So it's the most recent value and not the one in the closure, right? And we can define partial applications, which we have already seen earlier. All right, just reiterating some of these concepts again for recollection and revision. Let's move on to recursive functions. So here's a simple example of a function to compute the Fibonacci numbers. So here we have a function Fibo if n is less than or equal to 1, then return n, so this is 0 or the 1 case, else we call fibo of n minus 1 plus fibo of n minus 2, right? That's the definition. Let's check this. That looks fine. So then I'm defining u as a list of integers, 10 integers. Fun ID basically returns the integer itself, right? It's just the identity function. So now we can apply the map function to the fibo function and our initial list here, and so if you run this, we should get the Fibonacci series. This is a recursive function. Now we can do slightly better. There's a fibo loop here which basically eliminates this tail call here. So let's rewrite it slightly here with the fib loop definition. Say if I is equal to 0, then m, else we are calling fib loop of n into n plus m and I minus 1. Right, so we're just iterating there. We're removing the tail calls in the previous definition, and we're just defining fib 0, 1, and we can just call the initial 10 element list. So map takes a function and a list. So in our example here, we are calling the fib function. Here we should define with fib loop, and we're passing the list of integers, right? So if we run this, we of course get the same result, right? So we're eliminating the tail call in this definition. There are more examples of functions. So this is an example of functions with multiple parameters. So let's say we have sweetcat xy x, and we're just concatenating string. Let's run this. That looks fine. And we're calling sweetcat of kitty and cat with 2 strings. So we should just get a concatenated string of both the results, right? Now you can also have anonymous functions with multiple parameters. So the same function can be defined like takes a function x with argument x and returns another function takes argument y, and then we just concatenate the 2 values together, and then we can call sourcat of kitty and cat, and we should get the same result, right? So this example of using anonymous functions. Moving along, let's look at examples of partial application and closures. So here we're defining, let's sour kitty of x takes, that's one argument, and we're calling sourcat of kitty and x. We can define this sweet kitty, which takes, this is a function with takes an argument x and then calls sweetcat kitty and x, right? So either way we call sourcat with cat will basically concatenate or prepend the kitty in front, right? And then same thing with sweet kitty. It's going to just concatenate kitty and cat. So the result should be the same. Okay, so we're doing some partial application and we're using closures internally. So we can simplify these definitions. I can just simply call let soar kitty as sourcat of kitty, right? Welcome Sanath, how are you doing? We're just going through the values and functions, the rest of the values and functions in the Monday's edition, right? Let me paste the link to the docs. In the chat. Okay. Good luck for your interview. Oh, we're just going through this values and functions. We want to finish up with this session, and then we look at more of the OCaml docs in the coming sessions. All right, let's finish this definition here. We're simplifying the partial application. So, sweet kitty, sweet cat of kitty. Right, let's clear the output, and yeah, two definitions here. Now, an important point to remember in terms of types. So, if we define dummy cat, which takes 3 arguments, right, and we are sort of enclosing 2 of them in parentheses, and we are going to assign this to our sweet cat. We clear it and run it again, right. So it's a string, takes 3 arguments, a string and second string and a third string, right. Now we cannot define something like this here which will return an error for us, because this one is actually a function, right. So we are actually evaluating from right. So this one is treated as a function which takes a string and returns a string, but it's not what is actually the definition of sweet cat, and hence it will throw a error. So it says type string is not compatible with type string string. So the type arrow operator also says to the right, something you should remember. We can also operate on tuples as function parameters. Sanath is saying a coding challenge yesterday, went through 150 HackerRank problems. Oh, that's very good actually. You could actually try implementing in OCaml for some of these coding challenges. It'll be quite interesting for you to learn to apply functional programming style in your exercises and even in real work. It's a good opportunity to improve on writing clear, efficient programs. Very good. Let's I think we'll have more of these sessions, so feel free to join in and learn from these programming sessions here. Excellent. So we know how to define a tuple in OCaml. So this is an example of a tuple with a string and an integer, and here let's use a definition of spicy cat, which takes x and y and then just concatenates the tuple elements, right. It looks fine. So now if we call the function with hello and world, we should basically get the string hello world, right? So it's good. Let's briefly touch about the currying and uncurrying concept here. So it's very, very important in functional programming. So the idea here is that all functions, they take a single argument, and if you have further arguments, basically what it says is after taking the first argument, it returns a new function which takes the further arguments, right? So that concept is called currying here. So we have seen this example here regarding the parenthesis. So if we have string, so this is actually a function which takes a string and returns a new function which takes this, so curried function type. But if we just specify it without the parenthesis, then it's generally called uncurried function type. Of course, this is attribute to the logician Haskell curry. So let's see an example here. So we have let uncurried cat xy sweet cat of xy. Okay, that looks fine. So now when we define curried cat of xy, curried cat of, we actually put the parenthesis and definition looks good. So in practice, of course, curried functions are the default. They allow partial application, no parentheses or commas, and you cannot pattern match over a tuple, right? We have seen use of side effects in OCaml. So so if you take the definition of string of int, for example, as it takes an int and returns a string, right? So int is called the domain and string is called the codomain, right? So there are different types here. So with side effects, especially with I/O, you get for a input you might get different output, right? So this behavior is called a side effect. Now I don't have the Unix.time in the playground environment here, but I can definitely try the print line. So it takes a string and returns a unit value, right? So you've seen the example of, say, hello world, right? So it basically returns the string hello world, which is I/O example. All right. So what are the difference between functions and other values, right? So if you take sqrt, for example, it basically takes a float and returns a float, so it is a function, right? But what we cannot do is we cannot do equality testing between functions. So we take pred, this again takes integer and returns an integer. The same with successive, which takes an integer and returns integer. Now both the types are the same, but they don't necessarily mean to do the same thing, right? So you cannot do something like pred equal to success. You cannot do like equality testing between functions. So it returns invalid argument compared functional value. Okay. Okay. I think this pretty much covers the values and functions session for OCaml. Let me quickly show you where the videos from the past session are available. So I will make this video recording also available in this site. Let me paste it in the channel. Just open up YouTube, go to channel, videos, playlists, OCaml, and yeah. So you should be able to find the past video recordings also available on this channel. Sanath is asking, what are some of the books that you recommend for machine learning for web development, if you know of any? So there are two different things, right? I mean, web development is separate and machine learning is separate. So you have to like sort of focus on each. What I plan to do next is, if you go to my Twitch channel, let me mute this. Yeah. So we have in OCaml what is known as the Dreamweb framework, right? So I want to sort of go through the OCaml basics, and then I want to show how to use the Dreamweb framework to write some really cool applications. There is also the OWL project. I think it's called OCaml.xyz. So this is something OCaml specific, of course. So maybe if there is sufficient interest, we could try to do this. But of course, today there are a lot of existing programming languages and libraries and packages available to do machine learning and web development. I'm going to basically focus on how you can use OCaml to do tasks which is quite elegant to read, maintain, it's performant as well. This is the Dreamweb framework. There's some tutorial here as well. So once I finish OCaml, I'll probably go through the Dream usage tutorial and everything, so that it is useful to get going with these with OCaml. So I mean, then we will find plenty of resources available online as well. But I'm going to be focusing here on OCaml and the tools are an ecosystem platform around OCaml that you can use to quickly develop some of these web applications. But stay tuned, definitely with the familiarity with the syntax of OCaml and its usage and practicing some of these coding challenges, you will be able to quickly grasp the usage and start to write simple applications. Good question. There's something else I wanted to tell you today. Yeah, so I have been streaming on Mondays and Thursdays. If you look up my schedule, that's how it is. I will most likely be trying to do more sessions. Next week I am going to this OCaml retreat, which is being organized in Auroville, it's in Pondicherry in southern India. So few of that is colleagues, and we're also having developers who want to come and participate in the hacking of OCaml projects and learning new libraries, tools, working with the OCaml compiler, benchmarking, and so on. So we are going to be going to this retreat next week. I am going as well. So I don't know how the internet connectivity is going to be there, but I will try and see if I can stream from the retreat next week. Otherwise, I'll do a recording and I'll make it available on the YouTube channel. Let me paste this link to you as well, so it's useful. So the link to the Dreamwave framework is in my session here. We will be at the retreat next week. It's got limited number of seats. It's a good start for the year. Hopefully we can sort of make it happen every year. It's a nice place, La Vie en Rose in Auroville, and we have booked the whole place for hacking on OCaml. So it should be fun. I hope that some of you can make it to these OCaml retreats, either in India or abroad whenever we organize them. So it's going to be fun. Alrighty. So with that, let me first stop the recording. Any other questions that people have at this juncture? Alrighty.